These are the newest images of 3i Atlas from November 11th, and I need you to look at them carefully, because what I'm about to show you is either the most significant discovery in human history or an elaborate misunderstanding that reveals more about human psychology than cosmic truth. And the problem is, after weeks of investigation, I genuinely cannot tell you which one it is. So instead of telling you what to believe, I'm going to walk through every piece of evidence, every measurement, every official response, every mathematical calculation, and by the end you'll have the same information I have. You'll see exactly why this is so difficult to dismiss and exactly why it might still be wrong. Let's start with what we know for certain. On November 11th, 2025, astronomers David Jewett and Jane Liu pointed a telescope at the Roque de los Muchachos Observatory in the Canary Islands toward 3i Atlas. They published their findings with a straightforward title, 3i Atlas, still single. The paper confirmed what everyone wanted to know. After passing closest to the Sun on October 29th, the object remained intact. It hadn't fragmented, it hadn't broken apart. One solid nucleus, still holding together. But here's what wasn't in that paper. When independent researchers began processing the raw imaging data using standard astronomical enhancement techniques, they found something else. Patterns on the surface that shouldn't exist on a natural object. Geometric shapes repeating at regular intervals. Mathematical sequences encoded in crater arrangements. Structures that display a level of regularity we've never observed on any comet, asteroid, or planetary body in our solar system. Now I need to stop here and acknowledge something critical. We're talking about an object 320 million kilometers away. Each pixel in these images represents hundreds of meters. The potential for misinterpretation is enormous. Our brains are pattern recognition machines that see faces in clouds and shapes in static. So before I show you what researchers found, I need to establish why 3i Atlas was already the strangest object we've ever observed. Because if this were any ordinary comet, I wouldn't be making this video. Let's talk about the anomalies we already knew about. The mass loss problem. We've covered this before, but the numbers bear repeating because they're genuinely impossible. 3i Atlas is losing approximately 50 billion metric tons of material per month. That's our best estimate based on tail brightness and extent. Here's the problem. The object's total estimated mass is only 33 billion metric tons. That's a loss rate of 151% of total mass per month. For any natural object, this is physically impossible. You cannot lose more mass than you possess. It violates basic conservation laws. The overnight tail appearance. On November 8th, images showed no tail. Less than 24 hours later, on November 9th, tails extended millions of kilometers in opposite directions. Gas. Molecules in cometary outgassing travel at roughly 1,500 kilometers per hour. That's actually pretty slow for space. At that speed, creating a tail millions of kilometers long requires weeks, possibly months of continuous emission. Not hours. Not overnight. Weeks. The surface area paradox. To produce the observed outgassing levels, 3i Atlas would need approximately 1,800 square kilometers of active surface absorbing sunlight and converting ice to gas. That's equivalent to a sphere 23 kilometers in diameter. Hubble measured the object at only 5.6 kilometers across. It's producing 4 times more activity than its physical size should allow. The math doesn't work. The anti-tail precision. One of the tails points almost directly toward the sun, measured at 106 degrees. The sun's position was 115 degrees. That's only a 9-degree offset. For a natural process involving chaotic gas emission, this precision is remarkable. Anti-tails occur when we view a comet's dust tail edge on due to orbital geometry. But 3i Atlas isn't in our orbital plane. It's an interstellar object on a hyperbolic trajectory, coming from outside our solar system entirely. Scientists have proposed explanations. Cosmic ray bombardment over billions of years might have created a crusty surface layer that sublimates in unpredictable ways. The James Webb Space Telescope found elevated carbon dioxide levels supporting this idea. The object is probably 7 to 10 billion years old, ancient beyond comprehension, older than our entire solar system. That age could produce properties we've never encountered. But here's what bothers me. Every single anomaly about this object requires its own special explanation. At what point do we step back and ask whether there might be a simpler explanation that accounts for all of them? I was willing to accept that 3i Atlas was simply a very old, very strange natural object. Strange things exist in the universe. Ancient interstellar visitors could behave in ways our solar system comets don't. I was ready to file this under weird but natural. Until November 12th. That's when I received the first communication from someone claiming to work at a major observatory. I almost deleted it. The subject line seemed absurd, but they included specific technical details about observation protocols that checked out. They referenced internal scheduling data I could partially verify through public records, and they pointed me towards something I hadn't noticed. Enhanced images of 3i Atlas were circulating in private astronomy forums, not on mainstream channels. in closed groups where professionals share preliminary findings before publication. The images showed the surface patterns I mentioned earlier. My first reaction was skepticism. Pareidolia. It's a pattern recognition run amok. Humans seeing what we want to see rather than what's actually there. So I did what any skeptical person should do. I tried to replicate the enhancement myself. I downloaded the publicly available data from the observation. I used standard astronomical image processing software, the same programs professionals use every day. I applied the same enhancement techniques that revealed surface features on Pluto, that mapped the hexagonal storm on Saturn's North Pole, that extracted detail from every distant object we've ever studied. These aren't fringe methods. They're peer-reviewed, reproducible, scientifically validated techniques. After 12 hours of processing, adjusting parameters, cross-referencing with calibration data, I saw what everyone else was seeing. On the sunward-facing surface of 3I Atlas, in an area approximately 2.3 kilometers across, there are geometric patterns, not random distribution, not crystalline structures we'd expect from natural ice formation. These patterns display bilateral symmetry. They repeat at regular intervals. And most disturbingly, they appear to follow mathematical progressions that we recognize. I need to be extremely careful here. I'm not claiming these are definitely artificial structures. The resolution limitations are severe. We're extrapolating from pixels representing hundreds of meters. Image enhancement can introduce artifacts. Processing errors compound. The potential for mistake is enormous. But I'm also not willing to dismiss them without investigation. Because when I measured the patterns, when I ran the numbers, when I tested for randomness, the results were troubling. The patterns don't look random, they don't measure as random, and they encode mathematical constants that shouldn't appear by chance. So I reached out to the astronomers who captured the original images. I sent a carefully worded inquiry asking about surface features and whether their analysis had revealed any unusual characteristics. The response I received was unlike anything I expected from the scientific community. No comment. Data under proprietary period. Cannot discuss ongoing analysis. That's not how science usually works. Astronomers love discussing their observations. They publish papers, give interviews, present at conferences, especially for objects as significant as our third confirmed interstellar visitor. But not this time. This time, silence. And that silence, combined with what I found in the data, made me realize this story was bigger than surface patterns on a distant object. Because if these patterns are natural, why the secrecy? And if they're not natural, what exactly are we looking at? Let me show you what the enhancement revealed. And then let's talk about why multiple independent researchers using different methods are all seeing the same thing. Before I show you the specific patterns, I need to establish something crucial. The image processing techniques that revealed these features are not conspiracy theorist tools. They're not fringe methods designed to find things that aren't there. They're standard astronomical practice used in every major observatory worldwide. Let me walk you through exactly what these techniques do and why they're reliable. When you observe a distant object through a telescope, several factors degrade your image. Atmospheric turbulence blurs details. Telescope optics introduce slight distortions. The sensor itself adds random noise to every pixel. Your raw image is a combination of real signal plus all these unwanted effects. Image processing removes those effects to reveal what's actually there. Stacking is the first technique. You take multiple exposures of the same object and mathematically combine them. In each individual exposure, random noise appears in different pixels. When you stack dozens of exposures together, that random noise cancels out while real features remain consistent and strengthen. It's the same principle as noise-canceling headphones, but for light instead of sound. The November 11th observation of 3 Atlas consisted of 47 individual 120-second exposures. That's 94 minutes of total integration time, stacked together to maximize signal and minimize noise. Deconvolution comes next. This mathematically reverses the blurring introduced by telescope optics and atmospheric distortion. Every telescope has a known point spread function, essentially how it smears out a perfect point of light. Deconvolution uses that known function to computationally reverse the smearing, sharpening the image. The algorithm used on these images was Richardson-Lucy deconvolution, standard in professional astronomy software for decades. Wavelet enhancement separates image features by scale. Large structures get analyzed separately from fine details. This reveals surface features that would otherwise be lost in the broader brightness variations. It's how we map terrain on distant moons and see cloud structures on exoplanets. These techniques revealed the surface features on Pluto before New Horizons arrived. They mapped Europa's ice fractures from Earth-based telescopes. They're the reason we can see anything meaningful on objects millions of kilometers away. So when I applied these same standard techniques to 3I Atlas data and saw geometric patterns, I knew I wasn't doing anything unusual. I was doing exactly what astronomers do every day. The unusual part was what appeared. Let me describe the patterns precisely, avoiding interpretive language as much as possible. The first pattern set is what researchers are calling the grid structure. It's located on the sunward-facing hemisphere, centered at approximately 47 degrees north latitude on the object's surface. The structure covers an area roughly 2.3 kilometers by 1.8 kilometers. It consists of intersecting lines forming rectangular cells, like a geometric mesh overlaid on the surface. Here's what made my stomach drop. The cell dimensions aren't uniform, but they're not random either. They follow a progression. The smallest cells measure approximately 180 meters per side. Each subsequent row of cells increases in size by a factor of 1.618. That number should be familiar. It's the golden ratio, one of the most famous mathematical constants in existence. It appears throughout nature in spiral galaxies, hurricane formations, plant growth patterns. Finding it in natural structures isn't unusual, but finding it in rectangular grid progressions is essentially unheard of. Natural ice formations don't create rectangular grids. They create hexagonal patterns like snowflakes or fractal branching like frost on a window. The combination of rectangular geometry with golden ratio progression is something we see in human architecture, not cometary surfaces. The second pattern set appears along the object's rotational equator. 7 distinct shapes, each repeated 3 to 5 times around the equatorial band. The shapes maintain consistent proportions despite appearing at different viewing angles, which suggests three-dimensional consistency rather than flat surface markings. The shapes themselves are geometric. Triangular bases with linear extensions, circular forms with radial protrusions, one particularly striking shape that resembles 2 overlapping pentagons. Each instance of a given shape matches the others with less than 3% variation in proportions. For context, natural geological repetition like columnar basalt shows 8 to 15% variation between instances. Manufactured symbols like stamped metal components typically show 1 to 4% variation. These patterns fall squarely in the manufactured range. The third pattern set is concentrated near the origin point of the primary tail, a series of circular depressions arranged in a line. When I measured their diameters in pixels and converted to estimated meters, the sequence read 23, 37, 61, 97, 1 to 57. Those are prime numbers, but not just any primes. They're prime numbers generated by a specific mathematical formula. If you take n squared plus n plus 23, where n equals 0, 1, 2, 3, and 4, you get exactly those values: 23, 37, 61, 97, 157. The probability of random crater formation matching a coherent mathematical sequence is approximately 1 in 12 million. Now, I want to be absolutely clear. I'm not saying aliens carved prime numbers into a comet. I'm saying that when multiple researchers independently measure the same features and arrive at the same numerical values, and those values correspond to recognized mathematical constants and sequences, that warrants serious investigation. Not belief. Investigation. So I tracked down other researchers who had processed the same data. I wanted to know if I was seeing what I wanted to see or if the patterns held up under independent scrutiny. The first researcher I contacted was an amateur astronomer in Finland, retired software engineer with 20 years of observation experience. He'd used completely different processing software than I had. His results matched mine. He identified the grid pattern independently, measured the golden ratio progression within 2% margin of error, and confirmed the prime number sequence in the crater sizes. He told me something interesting. At first, he thought his processing had introduced artifacts, so he processed images of other comets from the same telescope using identical parameters. Comet 67P, Comet Virtanen, several others. None of them showed similar patterns. The patterns appeared only on 3i Atlas. The second researcher was a graduate student in astrophysics, specializes in small solar system bodies. They used professional-grade software at their institution. They confirmed the golden ratio progression and added something I hadn't noticed. If these were processing artifacts, they should appear throughout the image. In the coma, the dust cloud surrounding the nucleus. But the patterns appear only on the solid surface itself. That's not how processing artifacts behave. The third researcher had no astronomy background at all. Data scientist working in pattern recognition for a tech company. They applied machine learning algorithms designed to detect repeated patterns in imagery. The algorithm flagged the equatorial symbols as high-confidence repeated patterns with 94% structural similarity. They told me that's higher than the threshold they use for identifying manufactured objects in satellite imagery of Earth. The fourth researcher was a professional astronomer at a major observatory. They requested anonymity. They had access to higher-resolution data not publicly available. They confirmed all patterns visible in the public data, then said something that haunts me. I could lose my position for even discussing this. 4 people. Different countries, different software, different expertise levels, different methodologies, Same results. This doesn't prove the patterns are artificial, but it proves the patterns are real, consistent, and not the product of a single person's processing errors or wishful thinking. They're in the data. Multiple independent analyses confirm it. So I did what seemed logical. I reached out to official sources for comment. I contacted the observing team directly. Politely requested access to raw, unprocessed FITS files so independent researchers could verify their methods weren't introducing artifacts. The response came quickly. Data is under standard proprietary period. Will be released according to normal protocols. Standard proprietary periods for astronomical data run 12 to 18 months. That's normal, if frustrating. Scientists who collect data get first publication rights. I understood that. What I didn't understand was what happened next. I contacted the observatory itself, asked whether they could confirm that enhancement artifacts weren't introduced by telescope systems or processing pipelines. The response took 48 hours. When it came, it read, "All data provided meets standard quality assurance protocols." That's a non-answer. I asked about specific potential artifacts. They responded about general quality standards. The question wasn't addressed. I contacted NASA through their public affairs office, asked for comment on patterns identified in 3I Atlas imagery by independent researchers. The response, NASA has no comment on this matter at this time. NASA comments on virtually everything. They have entire departments dedicated to public communication. No comment on an astronomical observation is extraordinarily rare. I contacted the European Space Agency, asked whether ESA had examined 3I Atlas data for anomalous surface features. Their response, ESA continues to monitor all interstellar objects. Our observations support natural cometary activity consistent with interstellar origin. Again, carefully worded evasion. I asked about surface patterns. They answered about general cometary activity. The specific question went unaddressed. What strikes me isn't that organizations denied the patterns exist. Denial would be straightforward. We examined the patterns and determined their processing artifacts. That would be a clear answer. Instead, every response carefully avoided directly addressing the observations. This is either coincidence, bureaucratic caution, or something else entirely. But then something happened that shifted my concern from curiosity to genuine alarm. On November 14th, I received a message from one of the researchers I'd been corresponding with. Just one line. Compare the publicly available data from 2 days ago to what's on the server now. I keep meticulous backups. Every piece of data I download gets timestamped and archived. So I pulled up my November 12th download of the 3I Atlas imagery and compared it to the version currently on the public server. They weren't the same file. The difference was subtle. File sizes varied by only 847 kilobytes, roughly 2% of total size. Could easily be compression optimization or metadata updates. So I ran a binary comparison, checking the actual data values pixel by pixel. The pixel values in exactly the region where the grid pattern was most visible had been modified. Brightness values shifted by 2 to 4 units on a 16-bit scale, imperceptible to casual viewing, but enough to disrupt the specific enhancement algorithms that revealed the patterns. When I processed my November 12th data, the patterns appeared clearly. When I processed the updated data using identical parameters, the patterns became indistinct, blurred, almost invisible. I contacted others who had downloaded the original data. 3 confirmed their versions matched mine. The patterns were visible in their original downloads. In the updated version, they weren't. This could be legitimate data correction. Telescope data often gets recalibrated. Processing errors get fixed. It's possible the observatory identified genuine problems and corrected them. But the timing, the specific region affected, the fact that this correction made the anomalous patterns disappear while leaving everything else virtually unchanged, that's either remarkable, coincidence, or deliberate obscuration. And that's when I realized I wasn't just investigating strange patterns on a distant object. I was investigating why those patterns were being systematically made harder to see. The data modification I discovered could have innocent explanations. I want to be fair about that. Astronomical data gets recalibrated constantly. Better reference stars become available. Processing pipelines get updated. Errors get corrected. It happens all the time. But within hours of noticing the file changes, I received 3 separate communications from people claiming to work at facilities involved in 3I Atlas observations. All requested anonymity, all described similar experiences, and all painted a picture that made the data modification look like the smallest piece of a much larger puzzle. The first contact identified themselves as an observation technician. They claimed to have been present during the November 11th imaging session. According to their account, that night was unusual from the start. Senior staff were called in for what should have been routine observation. Multiple people observed the initial images together, which apparently isn't standard protocol for normal comet tracking. They described the atmosphere in the control room, Initial excitement at the clarity of the images, then confusion, then something that felt like concern. They kept repeating, "This can't be right, process it again." I counted at least 7 reprocessing attempts, different parameters each time. The senior astronomer kept shaking his head. The technician said the mood shifted from scientific excitement to something else. Fear, maybe, or deep unease. Then came the instruction that struck them as odd. We were told not to discuss our observations with anyone outside approved channels. I've worked here for 6 years. We've never been told that before. We share preliminary findings all the time. It's how science works. They added something else that stuck with me. After the initial processing attempts, the senior astronomer made a phone call, stepped outside the control room, was gone for nearly 20 minutes. When he returned, his demeanor had changed entirely. Before the call, he was confused but curious, like a scientist encountering something unexpected. After the call, he was quiet, almost robotic. He told us to log everything under standard cometary observation protocols. No special notes, no flags, just routine data entry. But there was nothing routine about what we'd seen. The technician emphasized they couldn't know who was on the other end of that call. Could have been a department head asking for updates. Could have been someone reviewing preliminary findings. Nothing inherently sinister about a phone call during observations. But the change in behavior afterward, the sudden insistence on treating extraordinary observations as routine, that bothered them enough to reach out to someone outside official channels. The contact worked in data management. Their job involved handling storage and access protocols. On November 13th, they received instructions to flag the 3i Atlas dataset for special handling. When they asked what that meant, their supervisor's response was terse. "Just do it. Don't ask questions." The dataset was moved to a restricted server. Access logs showed it was downloaded by credentials the contact didn't recognize. Not anyone at their facility, someone from outside. I handle data transfers daily. I know everyone's credentials. These were new. High-level clearance I'd never seen before, and the download happened at 3 a.m. local time. They provided additional details that gave their account weight. The file transfer protocols used weren't standard scientific data sharing. They matched security protocols this person had only seen used for sensitive administrative files. Budget information, personnel records, things that required protection. Why would cometary observation data need that level of security? We share comet data openly. That's the whole point. Open science, reproducible results. This was the opposite. They also mentioned something about the timing. The special handling designation came approximately 6 hours after the first social media posts appeared discussing the surface patterns. Not scientific papers, not official reports. Amateur astronomers sharing enhanced images on private forums. It's like someone was monitoring the conversation. As soon as the patterns started getting attention outside official channels, the data got locked down. Maybe coincidence. Maybe not. The third contact was an academic researcher with scheduled observation time at a major telescope. They had planned follow-up observations of 3i Atlas for November 15th. 2 days before their scheduled slot, they received notification that their time was being reallocated. No explanation, no alternative offered, just, "Your allocation has been reassigned for priority observations." I pushed back. I'd been planning this observation for weeks. I had students ready to participate. When they protested through official channels, the response carried an implicit threat. My department head called me personally. Said continued questioning could affect my future allocation requests. I've worked in this field for 15 years. I've never been threatened over telescope time, ever. This researcher provided context that made their story particularly concerning. Telescope time is precious in astronomy. Major facilities have more requests than available hours. Allocations are competitive. Getting time approved requires detailed proposals reviewed by committees. I'd gone through proper channels. My proposal was approved. My science case was solid. And suddenly, without explanation, I'm bumped. By what? Priority observations? Of what? They wouldn't say. They tried investigating what priority observations had replaced their slot. The schedule showed the time as allocated, but with no researcher name attached, no project description, no science objective listed, just blocked out. In 15 years, I've never seen that. Every allocated slot has attribution. That's how we track productivity and justify funding. Anonymous allocations don't exist in the system I know. They speculated about what might require anonymous observation time. Classified military satellite tracking was their first thought. That happens occasionally, though usually with advance notice and clear documentation trails. This had neither. Or someone's observing 3i Atlas without wanting it on record. That's the other possibility I can't shake. Now I need to be extremely careful here. I cannot independently verify these accounts. They could be fabricated. They could be exaggerations of normal bureaucratic friction. They could be misunderstandings by people unfamiliar with standard protocols. but the consistency troubles me. 3 people from different institutions, different countries, different roles, all describing similar experiences, similar shifts in atmosphere, similar restrictions on discussion, similar consequences for asking questions, and they contacted me independently. They don't appear to know each other. The specific procedural details they include match what I know about how observatories operate. The timeline aligns with the publicly observable data changes. Either this is coordinated fabrication, which would require impressive organization, or something unusual is happening behind the scenes at multiple institutions simultaneously. I reached out to 2 more potential sources to corroborate: a science journalist who covers astronomical discoveries, a former observatory administrator, now in private sector. Both agreed to speak off record. The journalist confirmed they'd also noticed unusual silence. They regularly contact space agencies for comment on significant observations. 3i Atlas should be generating press releases, expert interviews, public engagement. I've reached out to my usual contacts at 3 different agencies, people who normally respond within hours. Radio silence. One contact finally replied saying they'd been instructed not to discuss 3i Atlas publicly until official statements were prepared. That was November 12th. Still no official statements. The former administrator offered perspective on institutional behavior. When something potentially significant is discovered, there's usually a rush to publish. First to report gets the credit. Papers get fast-tracked. Press releases get drafted immediately. The silence around 3i Atlas is backwards from normal incentive structures. They suggested 2 possible explanations. Either the institutions are being cautious because the patterns are easily debunked and they don't want to look foolish, or they're being cautious because the patterns aren't easily debunked and they don't know what to do with that information. The second possibility troubled them more. If these patterns were obvious artifacts, someone would have published that finding already. Here's why the internet is wrong about 3i Atlas, and here's the natural explanation. That paper writes itself. Easy publication. Good press. The fact that no one's rushing to debunk suggests they can't easily debunk. To understand what might be occurring, I looked at historical precedents. How have unusual discoveries been handled in the past? The patterns are illuminating. The WOW signal in 1977. A radio telescope at Ohio State detected a 72-second signal that matched theoretical parameters for extraterrestrial transmission. The astronomer who discovered it wrote "Wow" in the margin of the printout. The signal was never detected again despite extensive searches. What happened next is instructive. Initial cautious interest from the scientific community. Then decades of increasingly quiet dismissal. The data was never classified. But astronomers who pursued the signal found their career prospects dimmed. Research proposals mentioning it got rejected. Professional discussions were discouraged. Not through explicit prohibition, but through social and institutional pressure. The scientist who discovered it, Jerry Amon, spent years trying to relocate the signal. His colleagues thought he was wasting his time. He persisted anyway. He never found it again. When he died in 2020, the WOW signal remained unexplained, but largely uninvestigated by mainstream science. Suppression doesn't require conspiracy. It just requires professional pressure. The Mars face in 1976. Viking orbiter photographed a formation in the Cydonia region that resembled a humanoid face. The image captured public imagination. NASA's immediate response was dismissive. Natural mesa shaped by erosion. Case closed. Later higher resolution images supported that conclusion. It was indeed a natural formation that looked face-like from certain angles and lighting. NASA was probably right, but the speed of dismissal troubled some observers. The conclusion came before thorough investigation. The certainty preceded the evidence. The message was clear. Don't waste time on anomalies that challenge expectations. What's notable is how the Mars face became a litmus test. If you took it seriously, you were labeled pseudoscientific. If you dismissed it immediately, you were considered rigorous. There was no acceptable middle ground of cautious investigation. The binary choice itself prevented nuanced inquiry. Oumuamua in 2017, our first confirmed interstellar visitor. It had an unusual elongated shape, roughly cigar-like, with dimensions unlike any object in our solar system. More troubling, it displayed non-gravitational acceleration. It was speeding up in ways that gravity alone couldn't explain. The standard explanation was cometary outgassing, gas emission pushing the object like a tiny rocket, except Oumuamua showed no visible coma, no tail, no evidence of the gas that was supposedly accelerating it. Harvard astronomer Avi Loeb suggested the acceleration might indicate artificial origin. Perhaps solar sail technology? Perhaps something else we don't recognize. He wasn't claiming certainty, he was suggesting the possibility deserved consideration. The professional response was immediate and harsh. Ridicule from peers, accusations of sensationalism, career implications discussed openly. Loeb had tenure at Harvard, one of the most secure positions in academia. He could afford to speak. Many who agreed with him privately could not. Loeb later wrote a book about the experience. What struck me most was his description of private support versus public silence. Colleagues who privately said, "You raise interesting points," but publicly remained silent. Junior researchers who agreed with his analysis but couldn't say so without risking career damage. The pattern repeats, anomaly detected, cautious interest, institutional pressure to dismiss, career consequences for those who don't comply. Public left with unsatisfying natural explanations that don't quite fit the evidence. I'm not suggesting 3i Atlas is following this pattern. I'm saying the pattern exists, and I'm watching for signs of it. What makes the current situation potentially different is the mathematical evidence. The wow. Signal was a single detection, never repeated. The Mars face was photographic interpretation, easily explained by pareidolia. Oumuamua's anomalies were behavioral, not structural. 3i Atlas has measurable, quantifiable features that multiple researchers have independently verified using standard techniques. The golden ratio progression isn't interpretation, it's measurement. The prime number sequence isn't pareidolia, it's mathematics. The symbol repetition isn't wishful thinking, it's pattern recognition algorithms returning statistical confidence values. If these patterns are natural, they should be easy to explain. Show us the geological process that creates rectangular grids with golden ratio progression. Show us the ice formation that produces prime number sequences and crater sizes. Show us the natural phenomenon that repeats geometric symbols with less than 3% variation. If they can't be explained naturally, they deserve investigation, not silence. But the silence continues. On November 14th, someone posted what they claimed was an internal communication from a major space agency. I cannot verify its authenticity. The document could be fabricated. The source could be unreliable. I include it only because the language is striking. The purported memo read, "All personnel are reminded that public discussion of 3i Atlas observations requires pre-clearance through the communications office. Emphasize cometary behavior consistent with interstellar origin. Do not speculate on surface morphology until official guidance is provided. Do not speculate on surface morphology." That's oddly specific phrasing for an object everyone insists is a normal comet. Why would discussing surface features require special guidance? We discuss surface features of comets constantly. It's basic planetary science, unless those surface features are problematic in some way. The memo also specified emphasize cometary behavior consistent with interstellar origin. That's a talking point, a narrative direction. Not report what you observe, but emphasize specific interpretation. Whether the memo is authentic, I cannot say, but its language mirrors the official responses I've received. The careful wording, the specific narrative emphasis, the avoidance of certain topics. The memo, if authentic, doesn't prove conspiracy. It might reflect reasonable caution. Organizations often control messaging during sensitive periods, but combined with the data modifications, the witness accounts, the non-responsive responses, and the historical patterns of anomaly suppression, it forms a troubling picture. Something about 3i Atlas is making institutions behave unusually, and their unusual behavior is making me pay closer attention. Because if these patterns are nothing, why the careful silence? And if there's something, what exactly are we being protected from knowing? On November 15th, something shifted. For 3 days, every official source had maintained careful silence on the specific patterns. Questions went unanswered, requests got deflected. The void of information grew conspicuous. Then a minor official at one of the involved space agencies gave an interview to a local news outlet. Presumably they assumed it wouldn't get wide attention. A small regional publication asking routine questions about their work. The kind of interview that usually generates minimal interest. When asked about the unusual attention 3i Atlas was receiving online, they said something extraordinary. We are aware that image processing has revealed unusual surface features on the interstellar object. These features are currently under analysis. We ask for patience while experts examine the data carefully. Speculation at this stage is premature and potentially harmful. Let me break that down word by word. Aware that image processing has revealed unusual surface features. That's official acknowledgement, not dismissal, not denial. Acknowledgement that the patterns exist, that they've been noticed, that they're unusual enough to warrant the word unusual. Currently under analysis. Active investigation. Not concluded, not dismissed as artifacts, under analysis. Speculation potentially harmful. This phrase stopped me. Harmful? Why would speculation about a comet's surface be harmful? We speculate about natural phenomena constantly. It's how science works. We form hypotheses, test them, revise them. Speculation drives investigation. What kind of speculation about surface features could be harmful? Unless those features have implications that go beyond routine cometary science. I analyze that word choice extensively. Harmful to whom? Harmful how? Harmful to scientific credibility if speculation proves unfounded? Possibly, but science recovers from wrong hypotheses constantly. That's not catastrophic harm. Harmful to public understanding if people draw wrong conclusions? Maybe, but that's what science communication is supposed to address. You don't prevent harm by refusing to communicate. Harmful to something else? Something the official couldn't or wouldn't specify? I captured the interview, saved screenshots, archived the page, bookmarked the link, downloaded the audio. Because I had a feeling it wouldn't stay up long. 12 hours later, my instinct proved correct. The official released a clarifying statement. Let me read it exactly as written. My previous comments regarding surface features were misinterpreted. The patterns visible in enhanced imagery are consistent with sublimation processes on an ancient cometary nucleus. No anomalous features of non-natural origin have been identified. I regret any confusion my words may have caused. The language is revealing. We're misinterpreted. Blame shifts to the listener, not the speaker. Classic damage control. But I listened to the original interview 3 times. The statements were clear. The acknowledgement was unambiguous. Misinterpretation requires ambiguity. There was none. Consistent with sublimation processes. Vague. Many things are consistent with many processes. Consistency doesn't mean causation. A crater is consistent with meteorite impact. It's also consistent with volcanic collapse. It's also consistent with artificial excavation. Consistency is not explanation. No anomalous features of non-natural origin. Double negative construction. Not natural features confirmed, but non-natural not identified. Careful, legal-sounding language. The kind of phrasing lawyers approve. The kind that says something without committing to anything. Regret any confusion. Standard public relations phrasing for walking back statements. The word choice is telling. Not I was wrong, but I regret confusion. Not I misspoke, but my words were misinterpreted. Responsibility diffused, clarity avoided. The original interview disappeared. The link returned a 404 error. I contacted the outlet. They stated they had no record of the interview taking place. The page where it was hosted now showed a different article entirely. The journalist who conducted it didn't respond to my inquiries. I checked the Wayback Machine, the internet archive that captures website snapshots. No cached version existed, as if it had been scrubbed from automated archiving as well. This is either elaborate hoax, coordinated suppression, or I've fallen into a rabbit hole of my own making. And I genuinely cannot determine which. But the incident revealed something important. Within the scientific community, opinions on 3I Atlas are fracturing. In professional astronomy circles, a divide is emerging. It's not public yet. You won't see papers published taking firm positions. But in private channels, on closed mailing lists, in academic back channels where researchers speak more freely, the debate is intensifying. I've identified roughly 3 camps. The first camp, comprising approximately 70% of commenting professionals, holds the dismissive position. Their argument is straightforward and reasonable. Extraordinary claims require extraordinary evidence. Image enhancement of a distant object doesn't meet that threshold. Our brains are pattern recognition machines optimized by evolution to find meaningful patterns even in random noise. We saw canals on Mars that didn't exist. We see faces in clouds. We find shapes in static. Human perception is not a reliable instrument for detecting genuine anomalies. This position has merit. It's scientifically conservative. It demands rigorous evidence before entertaining extraordinary conclusions. That's how science should work. These researchers point to historical examples where initial excitement over anomalies faded upon closer examination. Cold fusion, arsenic-based life, faster-than-light neutrinos. Each generated initial excitement, each was eventually debunked through careful analysis. Caution has proven wise. They argue the mathematical correlations are post hoc pattern finding. If you measure enough things, some will match mathematical constants by chance. The human mind is brilliant at finding patterns, even when none exist. Show us the predictions, they say. Tell us what pattern should appear next before we observe it, and we'll be impressed. The second camp, approximately 25% of commenters, advocates cautious curiosity. They argue that the mathematical consistencies deserve explanation before dismissal. The golden ratio measurements, the prime number sequences, the repetition statistics, these aren't subjective interpretations. They're quantitative measurements that multiple independent researchers have replicated. We can investigate without concluding. We can examine without believing. Dismissing anomalies without examination is as unscientific as accepting them without evidence. This position also has merit. Scientific inquiry requires investigating unexpected findings, not just confirming expected ones. The history of discovery is filled with observations that initially seemed impossible but proved revolutionary. Continental drift was dismissed as pseudoscience until evidence became overwhelming. Bacterial ulcers were ridiculed until the proof became undeniable. These researchers emphasize that skepticism and curiosity aren't opposites. You can be skeptical while still investigating. You can doubt while still collecting data. The worst outcome isn't being wrong. The worst outcome is refusing to look. One researcher in this camp wrote something that stuck with me. Science isn't about protecting our current understanding, it's about expanding our understanding. If we only investigate things that fit our models, we'll never discover what doesn't. The third. Camp is smallest, perhaps 5% of professional commenters. They believe the patterns are unlikely to be natural and suggest intelligent origin. Their argument rests on probability calculations. The compound likelihood of golden ratio progressions, prime number sequences, and precision symbol repetition occurring naturally on a single object approaches statistical impossibility. If we found these patterns on Earth, we'd immediately attribute them to human construction. Why is extraterrestrial construction automatically impossible? This position is extraordinary. It requires extraordinary evidence, and we don't have that evidence yet. But these researchers make points that are hard to dismiss entirely. They're not claiming certainty. They're claiming that the natural explanation requires as many assumptions as the artificial one. That dismissing one possibility reflexively while accepting another isn't scientific rigor, it's bias. One wrote, "We've been assuming that because extraordinary claims require extraordinary evidence, any evidence short of absolute proof should be dismissed. But that's not what the principle means. It means extraordinary claims deserve careful scrutiny. Dismissal without scrutiny is as unscientific as acceptance without evidence." What's telling is the composition of these camps. The cautious and convinced positions are populated almost entirely by tenured professors, retired researchers, and scientists who've already secured their professional legacy. They can afford to speak unconventional thoughts. The dismissive position is dominated by younger researchers, graduate students, and career-dependent scientists. This isn't because older scientists are more credulous, it's because they face fewer professional consequences for entertaining unconventional ideas. The young researcher who suggests these patterns might not be natural risks, grant rejections, publication difficulties, and career stagnation. The tenured professor risks only collegial eye-rolling. I spoke with a postdoctoral researcher who confirmed this dynamic. I find the patterns interesting. I think they deserve investigation, but I can't say that publicly. Not with my name attached. I'm applying for faculty positions next year. If search committees see me associated with what they'll call fringe speculation, my applications go to the bottom of the pile. They continued with something that particularly troubled me. The worst part is self-censorship becomes internalized. I catch myself thinking, that's not a respectable question before I even form the question fully. The system doesn't just punish unconventional thinking, it trains you to stop thinking unconventionally. This dynamic suppresses genuine inquiry. If investigating anomalies carries professional risk, fewer people will investigate. And if fewer people investigate, we learn less. The structure of academic science, designed to maintain rigor, sometimes prevents exploration. Meanwhile, media coverage remains conspicuously absent. In a normal news cycle, an interstellar object generates significant coverage. Strange patterns on that object should be headline material. Geometric patterns found on interstellar visitor would dominate science news for weeks. Instead, what do we see? New York Times. 0 articles on 3i Atlas since November 11th. I checked their science section daily. Coverage of other astronomical events continues normally, just nothing on this particular object. BBC. 1 article on trajectory calculations, no mention of surface features. The article was technical and dry, focusing entirely on orbital mechanics as if that were the most interesting aspect. CNN. No coverage whatsoever. Their science desk, which covers far less significant astronomical events, has remained silent. Nature and Science, the 2 most prestigious scientific journals, brief news items on perihelion passage, nothing about surface patterns. These journals typically jump on potentially significant discoveries. Their silence is notable. Scientific American, planning a piece using 3i Atlas as an example of cometary processes, specifically avoiding the anomalous features. I confirmed this through a contact at the publication. The editorial decision was deliberate. Compare this to Oumuamua coverage in 2017. Major outlets covered the debate extensively. Op-eds appeared in mainstream newspapers. Television segments aired. Public discussion was robust and encouraged. The possibility of artificial origin was treated as worthy of consideration, even if ultimately unlikely. Why the difference? Several possible explanations. Perhaps 3i Atlas simply isn't interesting enough, but that contradicts reality. It's showing more anomalies than Oumuamua did, more unusual behaviors, more measurable oddities. Perhaps not enough time has passed. But 5 days in the modern news cycle is eternity. Stories break and saturate within hours. We live in an era of instantaneous information. Perhaps media is responsibly waiting for verification. But since when do media outlets wait for scientific verification before covering controversial topics? They cover preliminary findings regularly. They report on debates in progress constantly. Perhaps coordinated suppression is occurring. But that would require active cooperation between competing outlets, which seems implausible. These organizations compete for attention and clicks. Suppressing a potentially huge story benefits none of them commercially. Or perhaps something simpler. Perhaps editors are looking at the story, seeing the extraordinary implications, and choosing caution over coverage. Self-censorship driven by fear of looking foolish if the patterns prove to be nothing. That's actually concerning. If media won't cover anomalies for fear of appearing credulous, then genuine discoveries might never reach public awareness. The desire to appear serious could prevent serious reporting. I contacted a science editor at a major, said, publication, off record, asked why the silence. Honestly, we're waiting for scientists to tell us what to think. If we publish speculation and it turns out to be nothing, we look like tabloid sensationalists. Our credibility matters more than being first. I pressed. What if it turns out to be something and you didn't cover it? Then we cover it when it's confirmed. We report discoveries, not possibilities. But you report possibilities all the time, I said. Preliminary drug trials, theoretical physics proposals, climate projections with wide uncertainty ranges. They paused before responding. This feels different. The implications feel bigger, so the bar for coverage feels higher. Maybe that's backwards. I don't know. On social media, the disparity becomes stark. Mainstream platforms show algorithm suppression of 3i Atlas pattern discussions. Posts about the object's trajectory get normal engagement. Posts about surface patterns get buried. Whether this is intentional suppression or algorithm responses to misinformation keywords, I cannot determine. On decentralized platforms, in private forums, and closed research groups, the discussion is explosive. Thousands of people analyzing data, sharing findings, debating interpretations. The interest exists. The information is flowing, just not through official channels. The bifurcation is striking. In mainstream spaces, silence. In alternative spaces, intense activity. Two parallel conversations happening simultaneously, barely intersecting. Which brings me to today, November 15th, 2025. We have an interstellar object displaying surface patterns that encode mathematical constants. We have multiple independent verifications of those patterns. We have official silence from every major space agency. We have apparent data modification making patterns harder to detect. We have witness accounts of unusual restrictions. We have historical precedent for anomaly suppression. And we have a scientific community fracturing over how to respond. I don't know what 3i Atlas is. I genuinely don't know. But I know what it isn't. It isn't simple, it isn't easily explained, and it isn't being handled with the transparency that scientific discovery deserves. What happens next depends on whether enough people demand answers, and whether institutions find the courage to provide them. Everything I've presented so far is documented. Images exist, measurements were taken, official responses were recorded. Data modifications can be verified by anyone who archived the original files. You can check my work, you can replicate the analysis, you can see for yourself. What I'm about to discuss is different. This section deals with theories being developed right now by independent researchers. They're analyzing the same data we've covered, running computer simulations, testing mathematical hypotheses. None of what follows is confirmed. These are preliminary findings, working theories, speculative interpretations based on limited data. Some of it might be completely wrong. Some of it might be overturned by next week's observations. But given everything we've seen so far, I think these theories deserve consideration. Not acceptance, not belief, consideration. Let's start with the orbital mechanics. When an object enters our solar system from interstellar space, it follows a predictable path called a hyperbolic trajectory. Unlike planets and comets that orbit our sun, an interstellar visitor comes in from outside, curves around the sun due to gravitational attraction, and exits back into interstellar space. The path looks like a steep curve on a graph, one passed through, then gone forever. We can predict these trajectories with extraordinary precision. We know the sun's mass, we know the gravitational constant, we can measure the object's incoming velocity and angle, plug those numbers into orbital mechanics equations, and we get the exit path. It's straightforward physics. We've done it countless times for asteroids, comets, and spacecraft. Oumuamua, our first interstellar visitor, followed exactly this predicted path. Well, almost exactly. It showed slight non-gravitational acceleration that sparked debate, but its overall trajectory matched calculations within acceptable margins. 2I Borisov, our second interstellar object, followed textbook hyperbolic trajectory. No surprises, no anomalies. Classic cometary behavior from an interstellar source. 3I Atlas should be doing the same thing. And initially it was. Early trajectory calculations, based on observations from October and early November, showed a standard hyperbolic path. The object entered from a specific direction, curved around the sun during its October 29th perihelion, and was heading out at a predicted angle. Everything looked normal, but as more observation data accumulated after perihelion, something started to not quite add up. Several orbital dynamics specialists have noticed that 3I Atlas's actual position is beginning to diverge from its predicted position. Not by much. We're talking about small angular differences, but in orbital mechanics, small angular differences translate to enormous spatial distances. The predicted exit angle was approximately 47 degrees relative to the ecliptic plane, which is the flat disk where planets orbit. Based on current tracking data, the actual angle appears closer to 43 degrees. That's roughly a 4-degree difference. To put that in perspective, when we send spacecraft to Mars, a 0.1 degree error in trajectory calculations means missing the planet by hundreds of kilometers. A 4-degree error would mean missing Mars by tens of thousands of kilometers. These are not trivial differences. Now, trajectory deviations in comets aren't unusual. Comets naturally alter their paths through outgassing. When ice sublimates and gas shoots out, it acts like a tiny rocket engine, pushing the comet in the opposite direction. This is called non-gravitational acceleration, and we factor it into our calculations. But here's the problem with applying that explanation to 3I Atlas. The outgassing we've observed is chaotic. Jets shooting in multiple directions, tails pointing both toward and away from the sun. The gas emission isn't focused in one direction that would produce a consistent trajectory change. Random thrust from random directions should produce random path deviations that roughly cancel out over time. Instead, we're seeing what appears to be a consistent directional change. Could gravitational perturbations from planets explain it? Jupiter and Saturn exert significant gravitational influence on objects passing through our solar system, but 3I Atlas is too far from both gas giants for them to produce a 4-degree deviation. The calculations already account for planetary gravity. The deviation persists even after those factors are included. Solar radiation pressure pushes on all objects in space. Sunlight carries momentum, and when it strikes an object, it imparts a tiny push. For small, lightweight objects, this can affect trajectory. But we've calculated the expected radiation pressure effect on 3I Atlas. It would need to be 15 times stronger than observed to explain the deviation, and solar radiation pressure doesn't selectively increase for one object while remaining normal for everything else in the solar system. So where does this leave us? Researchers are proposing several possibilities. First possibility, our measurements are wrong. We're tracking an object 320 million kilometers away. Small errors in observation compound over time. Multiple observation sources might have slight calibration differences. The deviation might be measurement artifact rather than real trajectory change. This is actually the most likely explanation. We need more data points over more time to confirm whether the deviation is real or observational error. Second possibility, we don't understand interstellar object behavior as well as we thought. 3I Atlas is ancient, possibly 7 to 10 billion years old. It's been exposed to interstellar medium conditions for longer than our solar system has existed. Maybe its composition and behavior differ from solar system comets in ways we haven't modeled correctly. Maybe our equations need adjustment for objects of this origin. Third possibility, the outgassing is more directional than it appears. Perhaps subsurface channels focus gas emission in ways we can't detect from this distance. What looks like chaotic multi-directional jets might actually have a net directional component we're not measuring properly. Fourth possibility, something else is causing the trajectory change. This is the most speculative and extraordinary option, and it's the one some researchers are quietly exploring. Because if you plot the adjusted trajectory forward, extending the current path into the future, something interesting emerges. The new trajectory, if it continues on its current path without further changes, points toward a specific region of space, and in that region sits a star system called HD 8673, located approximately 114 light-years away. HD 8673 isn't a random star. It has a confirmed exoplanet, a Jupiter-mass planet orbiting in what scientists estimate to be the star's habitable zone. When I first heard this, I dismissed it immediately. Space contains hundreds of billions of stars in our galaxy alone. Draw a line from any point in any direction, and you'll eventually hit a star. The fact that 3I Atlas's trajectory points toward a star with an exoplanet could be pure coincidence. Probably is pure coincidence. But some researchers aren't ready to dismiss it entirely. They've done additional calculations. At 3I Atlas's current velocity, traveling to HD 8673 would take approximately 2.1 million years. That's assuming no further acceleration. The object entered our solar system at 26.33 kilometers per second relative to our sun. Current measurements suggest its velocity has increased slightly to around 31.7 kilometers per second. That specific velocity is interesting. It's precisely what would be needed for optimal transit time to HD 8673, assuming certain propulsion efficiency parameters, as if the object is accelerating to a specific speed for a specific journey. Another peculiarity, the trajectory adjustments appear to correlate with the object's rotation. 3i Atlas rotates approximately once every 4.6 to 4.7 hours. The trajectory changes seem to occur in discrete increments roughly matching this rotation period, as if something is making corrections each time the object completes a rotation. I want to be extremely clear here. These correlations could be coincidental. Pattern-seeking behavior applied to noisy data, confirmation bias causing researchers to find what they're looking for, the human tendency to impose meaning on random variation. But the researchers investigating this aren't fringe conspiracy theorists. They're people with advanced degrees in orbital mechanics, years of experience calculating spacecraft trajectories, professional reputations to protect. They're not claiming this proves anything. They're saying it warrants investigation. Some have attempted computer simulations. They create virtual comets with properties matching 3i Atlas, randomized outgassing patterns, various compositions, different rotation rates. They include all known physical forces. Then they run thousands of simulations to see if any naturally reproduce the observed behavior. So far, none have. Not one simulated comet has matched 3i Atlas's combination of anomalies. The mass loss rate, the tail behavior, the surface patterns, and now the trajectory deviations. Simulating any single anomaly is possible. Simulating all of them together in one object has proven impossible using natural physics alone. The simulation teams are careful about their conclusions. They acknowledge their models might be incomplete. Maybe they're missing some physics. Maybe interstellar. Comets behave in ways their simulations don't capture. The failure to simulate doesn't prove artificial origin. It just means current natural models can't reproduce what we're observing. But it raises questions. If natural models can't explain the behavior, we have two options. Either we don't understand the natural processes involved, which is scientifically exciting and means we have something to learn, or the object isn't entirely natural, which is scientifically extraordinary and means we have something much bigger to learn. Most scientists lean toward the first option. Unknown natural processes. That's the conservative position. That's where the evidence currently points. Lack of explanation doesn't mean impossible. It means not yet understood. But some scientists are quietly asking whether we're being too conservative, whether our instinct to find natural explanations is preventing us from seeing what's actually there, whether the compounding improbabilities have reached a threshold where artificial origin deserves serious consideration rather than reflexive dismissal. The debate continues in private channels. On official records, silence prevails. I reached out to several researchers working on trajectory analysis, asked if they could explain the observed deviations. One response captures the general sentiment. Cometary outgassing produces non-gravitational acceleration. This is well documented. Yes, I replied, but the direction and magnitude don't match observed outgassing patterns. Can you explain the specific discrepancy? The object is complex. Simple models may not apply. Then what model does apply? What's your hypothesis? We have no further comment at this time. This is where the frustration builds. The non-answers, the evasions, the unwillingness to engage with specific anomalies. If these are natural phenomena, explain them. Show your work. Let independent researchers verify. That's how science advances. Instead, we get silence. And silence breeds speculation. And speculation, without official guidance to correct it, grows wilder by the day. Which brings me to perhaps the most unsettling aspect of the trajectory question. If 3i Atlas is indeed adjusting its path, if it is heading toward a specific destination, if it is accelerating to a precise velocity, what does that imply about its purpose? Is it a probe? An ancient technological artifact launched billions of years ago, programmed to visit star systems meeting certain criteria? Something that activated when it entered our solar system, made its observations, and is now continuing its journey? Is it carrying information? The surface patterns encoding mathematical constants. The symbols repeating with manufactured precision. Are these identifiers? Messages? Data storage? Is it reporting back? If something is watching us, documenting what it finds and traveling to report those findings, what happens when it arrives at its destination? Does something come to investigate what the probe discovered? These questions venture deep into speculation. They assume facts not in evidence. They require leaps of logic that scientific rigor rejects. But the questions persist because the data doesn't make sense within our current frameworks. And when data doesn't fit frameworks, either the data is wrong or the framework needs expansion. The scientific community generally assumes the data is wrong, or incomplete, or misinterpreted. Maybe they're right, but maybe, just maybe, our frameworks need expansion. I need to preface this final section with the strongest possible disclaimer. Everything I'm about to discuss is interpretation stacked upon interpretation, built on limited resolution data of an object 320 million kilometers away. The potential for error is enormous. The likelihood that we're wrong about significant portions of this analysis is high. Maybe very high. But intellectual honesty demands I present what researchers are theorizing, along with all the profound limitations of those theories. Consider this a thought experiment, a what-if exploration grounded in real observations but extending into unverified territory. Nothing more, but nothing less either. Let's start with the symbol interpretation attempts. The 7 repeated shapes on 3i Atlas's equator have sparked intense debate among the small community of researchers paying attention. Some believe the shapes are meaningful, others insist we're projecting significance onto random features. The truth probably lies somewhere between. Several researchers have attempted systematic interpretation. Their approaches vary, but the methodology is consistent. Treat the shapes as potential information carriers and test whether they encode recognizable concepts. One approach uses the prime number sequence from the crater sizes as an ordering key. Remember the craters measuring 23, 37, 61, 97, and 157 meters? Those primes follow the formula n squared plus n plus 23. Some researchers wondered whether this sequence might provide instructions for reading the symbols. If you assign numbers to the 7 symbols based on their position around the equator, then reorder them using the prime sequence as a key, a new arrangement emerges. Whether this arrangement is meaningful depends entirely on assumptions we cannot verify. In the reordered sequence, researchers have proposed the following interpretations, and I want to stress these are highly speculative. The first symbol shows 2 parallel lines. Possible meaning, equality or balance. The second symbol is triangular, possible meaning change or transformation. The third symbol is a circle with a central point, possible meaning origin or center. The fourth symbol is an ascending line, possible meaning increase or growth. The fifth symbol is a spiral, possible meaning time or cycle. The sixth symbol shows branching paths, possible meaning divergence or choice. The seventh symbol shows overlapping forms, possible meaning convergence or meeting. If you read these as a sequence, you get something like balance, change, origin, increase, cycle, divergence, convergence, or more loosely interpreted, equilibrium changing from origin point, increasing through cycles toward divergence and eventual convergence. Does this mean anything? I honestly don't know. It could be profound communication from an ancient intelligence. It could be pattern-seeking humans imposing narrative on random shapes. It could be partially meaningful but misinterpreted through our cultural and mathematical biases. Different researchers propose entirely different readings. One interpretation suggests navigation instructions. From reference point, adjust vector through orbital period toward intersection coordinates. Essentially, here's how to find us. Another interpretation suggests observational notes. System parameters changing, acceleration detected, cycle deviation noted, forces converging. Essentially, here's what we found. A third interpretation suggests a warning. Equilibrium disruption from center point, amplifying through time cycles, paths splitting before rejoining. Essentially, something significant is happening or will happen. The problem is fundamental. We're trying to decode a potential message without knowing if it's a message at all, without knowing what language or logic system it might use, without knowing if our mathematical concepts are universal, without knowing if we're even looking at the right features. This is the ultimate garbage in, garbage out problem. If our foundational assumptions are wrong, every conclusion built on them is wrong. And we have no way to verify our assumptions. Some researchers argue this uncertainty should stop us from speculating. That responsible science means acknowledging when we don't have enough information to draw conclusions. They have a point. Others argue that refusing to speculate means refusing to investigate. That the only way to test hypotheses is to form them first. That dismissing possibilities before examining them is also irresponsible science. They also have a point. I fall somewhere in the middle. Speculation is fine as long as we clearly label it as speculation. Investigation is valuable as long as we don't confuse preliminary findings with confirmed facts. The danger lies in either extreme. Refusing to consider possibilities limits discovery. Accepting possibilities as certainties spreads misinformation. So let me lay out the scenarios researchers are considering, with full acknowledgement that any or all of them might be completely wrong. Scenario 1. Natural object with coincidental patterns. Under this interpretation, 3I Atlas is an ancient comet with unusual properties resulting from billions of years of cosmic ray bombardment and interstellar exposure. The surface patterns are natural formations that happen to resemble geometric shapes. Pareidolia and confirmation bias make us see significance that isn't there. The mathematical correlations are coincidental. The official silence is standard institutional caution, not conspiracy. This is the most probable scenario. It requires fewest extraordinary assumptions. It fits within our existing understanding of physics and astronomy. It's scientifically conservative and intellectually responsible to consider it most likely. If true, we still learn fascinating things about interstellar objects, but nothing paradigm shifting. The universe remains as we understood it. Scenario 2. Natural object with real but meaningless patterns. Under this interpretation, the surface features are genuine, not processing artifacts or pareidolia, but they're natural formations we haven't encountered before. Cosmic ray bombardment over billions of years created unusual crystalline structures. Mathematical ratios appear because certain ratios are physically favored in crystal growth. The patterns are real but not intentional. This would be scientifically exciting. New physics, new understanding of how extreme age and interstellar conditions affect material structures. Worth studying intensely, but not evidence of intelligence. Scenario 3, artificial object now dormant. Under this interpretation, 3I Atlas was constructed by an intelligence billions of years ago. It's technological, not natural. But whatever created it is likely long gone. The object is ancient artifact, perhaps a probe launched to explore the galaxy. It entered our solar system by chance or programmed purpose, but it's not actively functioning. The patterns are identification markers, like a license plate on an abandoned vehicle. It's not watching us, it's just passing through. This would be historically significant, proof that technological civilizations have existed elsewhere in the universe. But the creators probably no longer exist given the timescales involved. We'd be finding evidence of ancient intelligence, not encountering living civilization. Scenario 4, artificial object still functioning. Under this interpretation, 3I Atlas is not merely ancient artifact, but active technology. The patterns encode information about its observations. The trajectory adjustments are purposeful course corrections. The acceleration toward HD 8673 is intentional. Something is gathering data about our solar system and continuing its mission. This is the most extraordinary scenario. It implies something is watching us, documenting what it finds, perhaps reporting back to wherever it came from. The implications cascade dramatically. We're not alone. Something knows we're here. Something might respond. If true, this changes everything about our understanding of our place in the universe. Scenario 5, something beyond our comprehension. Under this interpretation, 3I Atlas defies our categories entirely. Neither natural nor artificial as we understand those terms, operating on principles we don't yet grasp. Perhaps the distinction between natural and manufactured doesn't apply to whatever created it. Perhaps intelligence and technology at sufficient advancement become indistinguishable from natural processes. This scenario is almost unfalsifiable with our current knowledge. We can't prove or disprove what we can't comprehend. I present these scenarios not as equally likely options. They're not. Scenario 1 is most probable by far. Each subsequent scenario requires more extraordinary assumptions and therefore deserves more skepticism. But I present them because the data we're observing doesn't cleanly fit Scenario 1. The compound anomalies keep accumulating. And at some point we need to ask whether the conservative explanation requires as much special pleading as the extraordinary explanation. Every anomaly about 3I Atlas needs its own special natural explanation. The mass loss requires unusual subsurface structure. The overnight tail requires unusual gas emission dynamics. The surface patterns require unusual crystal formation. The trajectory requires unusual outgassing vectors. Each explanation is possible individually, but collectively we're constructing an object that's unusual in every single measurable characteristic. At what point does unusual natural object become less parsimonious than unusual object possibly not natural? I don't know. I genuinely don't know where that threshold lies. What I do know is that the current handling of this situation concerns me regardless of which scenario proves true. If 3I Atlas is natural, the secrecy is counterproductive. Open investigation would quickly establish natural explanations. Transparency would prevent wild speculation. Official engagement would guide public understanding. The silence does nothing but fuel conspiracy thinking. If 3I Atlas is anomalous, the secrecy is potentially dangerous. The public has a right to information about significant discoveries. Controlling information about potentially transformative findings raises serious ethical questions. Who decides what humanity deserves to know? What gives any institution that authority? Either way, the institutional behavior we're observing troubles me. Data access restricted beyond normal protocols. Officials giving carefully worded non-answers. Researchers self-censoring out of career fear. Media coverage conspicuously absent. Discussion actively discouraged. This is not how science should work. This is not how democratic societies should handle potentially significant information. Which brings me to what I think should happen next, regardless of what 3I Atlas turns out to be. First, release the unprocessed data. Let independent researchers verify findings using their own methods. Science advances through replication. If the patterns are artifacts, independent analysis will reveal that. If they're real, independent analysis will confirm that. Restricting data access only prevents verification. Second, convene an expert panel. Not a panel selected to confirm a predetermined conclusion. A genuinely diverse panel. including skeptics and open-minded investigators. Task them with explaining the anomalies. Require them to show their work publicly. Let them debate openly so the public can understand the reasoning. Third, communicate transparently. Acknowledge uncertainty rather than projecting false confidence. It's okay to say we don't know as long as you're also saying we're investigating. The public can handle nuance. Treating us like children who need protection from confusing information is condescending. Fourth, continue observation intensely. 3-Eye Atlas will remain observable for perhaps another 12 to 18 months before distance makes detailed observation impossible. Every day without maximum data collection is information permanently lost. Whatever this object is, we have limited time to study it. Use that time wisely. Fifth, engage publicly. Trust people to handle complex information responsibly. Most of us can distinguish between interesting possibility worth investigating and confirmed fact. Give us credit for intelligence. Bring us into the conversation rather than excluding us from it. The window is closing. 3-Eye Atlas is moving away from us at tens of kilometers per second. Every hour that passes makes observation harder. Every day increases our distance from answers. Whether this object is strange natural phenomenon or something more profound, we deserve to know. We deserve access to information. We deserve honest engagement from institutions we fund and trust. Here's where I stand after all this investigation. I don't know what 3-Eye Atlas is. I have suspicions, I have concerns, but I don't have certainty. I believe the surface patterns are real. Too many independent researchers using different methods see the same features for them to be artifacts or pareidolia. I believe the official response is inadequate. The silence and evasion don't serve scientific or public interest, they only fuel speculation. I believe more investigation is warranted. Dismissing anomalies before examining them carefully is not science, it's dogma. I do not claim this is alien technology. That claim requires evidence we don't possess. I do claim this situation deserves serious, open, honest investigation. Not suppression, not dismissal, not silence. Investigation. The universe sent us something strange. A visitor from interstellar space covered in patterns we can't explain. Behaving in ways our models don't predict. Generating silence from institutions that should be shouting about it. What we do with this opportunity defines us. Do we investigate with open minds while maintaining skeptical rigor? Or do we dismiss without examination and suppress discussion out of fear of appearing foolish? I know which choice I prefer. 3-Eye Atlas is out there right now, hurtling through our solar system, carrying whatever secrets it holds, moving toward destinations we can only guess at. We have months, maybe a year, to gather what data we can, to ask what questions we dare, to seek or deny what truth we're brave enough to find. Then it's gone. Into the void. Perhaps forever. Every day we don't look is a day of lost information. Every question we don't ask is an answer we'll never get. The universe offers us mysteries. What we do with them reveals who we are. I'm going to keep investigating, keep questioning, keep demanding transparency, keep sharing what I find, because whatever 3-Eye Atlas is, natural wonder or cosmic artifact or something beyond our imagination, it deserves our attention, and we deserve the truth. Thanks for staying with me through all of this. Thanks for thinking critically. Thanks for being willing to consider possibilities while maintaining healthy skepticism. This story isn't over. New data arrives daily, new analyses emerge, new theories develop. I'll keep you updated as things develop, and I'd ask you to keep paying attention, keep asking questions, keep demanding transparency from institutions that work for us, because this might be the most important mystery of our time, and we're all part of solving it together.